Students, we'll talk a little bit about the structure of a circuit switch. Students, the last topic before we leave this discussion of switching. Circuit switch is what we normally use on the physical layer. Students, there are two basic types of circuit switches. The first one is a space division switch, and then you have got a time division switch. Students, there are two types of the space division switch. The first one is called a crossbar switch, and the second one is a multi-stage switch. Students, let's go through each one of them one by one. So the first switch that we have is called a crossbar switch. Students, as you can see, the crossbar switch, it actually connects N inputs to M outputs. So in a crossbar switch, you would normally have N inputs and M outputs. Students, in this example that you're looking at, your N is equal to 3 and your M is equal to 4. Students, in a crossbar switch, you normally work with a grid. As you can see, you have got a grid which is combining the inputs with the outputs. Students, the crossbar there is a cross point in there as well. So multiple small blue dots, they are actually showing as the cross point, and then there is a control station in there. Students, the major limitation of this type of a switch is the number of cross points required. It actually literally kills the case for a cross point. So if you've got a limited number of inputs and a limited number of outputs, yes, the cross bar switch probably works fine. But for example, in this case, as you can see, the number of cross points that you require is equal to M, N multiplied by M. So you require, for a 3 input and a 4 output crossbar switch, you require 3 multiplied by 4, which is equal to 12 total cross points. Works fine for a small number of inputs and small number of outputs, isn't it? Students, now let's consider if you've got 1,000 inputs and 1,000 outputs. Students, a crossbar switch with this many number of cross points is completely impractical. Students, even if we manage to get such a crossbar switch, it will be very inefficient, and the reason for that is that we have got a stats which says that fewer than 25% of cross points are normally used in a crossbar switch at one single time. Students, the solution to this limitation of the crossbar switch is multistage switch. Students, as you can see, this particular switch, it combines the crossbar switches in several stages. So you've got N by N crossbar, you've got K crossbars, and you've got N by N crossbars once again. 3 different stages. Students, in a single crossbar switch, only one row or column is active for any particular connection. The other rows or columns, they are not active. Students, what it does is, what this multi-stage switch does is, it actually allows us to have N by N cross points, where your N is actually the capital N. And so in this 3-stage switch, for example, that you're looking at, the total number of cross points is represented by, this is represented by 2kn plus small k into n over n square. Now students, in the case of crossbar switch, we had the number of cross points as n square. Students, this particular number is a lot lesser and realistic than n square. अब students, बात करेंगे about the second type when it comes to the structure of a switch, and that's a switch that uses time division switching. Students, in this particular case, the time division switch, it uses TDM inside it, And the most popular type of this time division switch is called a time slot interchange, or TSI. Students, on the slide you can see that we have a time slot interchange switch, or a TSI. And we have got, there are 4 input lines and there are 4 output lines in this particular case. So there are 4 inputs, 4 outputs. Students, what we need to do is, we want to send the data from the input to the output according to the following pattern. This is the pattern that we want to achieve. 1 to 3, 2 to 4, 3 to 1, and lastly 4 to 2. Now students, as you can see, we have got this TDM side, this switch. It combines our TDM multiplexer. It has our TDM demux, and there is a TSI which consists of a RAM. So in the middle, you've got time slot interchange. It consists of a RAM, and there is a control unit. Students, what's happening is that the size of each location, in this case, is the same of the size of a single time slot. Students, the number of locations that are there in this RAM, the number of memory locations, they are the same as the size of time slots. Students, the RAM first fills up with the incoming data from the time slots in the order that it's received. Yes, slots, they are then sent out in the order based on the decision of a control unit, and therefore we achieve the paths via this TDM switch from 1, for example, based on this selectively controlled switch. If it's in the first position, this goes to 3, and we achieve 1 to 3 using this time division switch. Students, the advantage of this time division switch is that it needs no cross points. So we get rid of that issue that we had with large number of inputs and outputs and the cross points. And the advantages are that in the case of this TSI, the processing that each connection creates, it causes a little bit of delay. So that each time we have a slot, it must be stored by the RAM, then retrieved, and then passed on. We encounter a little bit of a delay.